Hi, my name is Ryan Sanders, and what I want to talk about today is the role that cryptographic keys and digital certificates play as your enterprise makes this shift from kind of highly contained infrastructure that runs within your enterprise network to the multi-cloud and dispersed infrastructure that we see in many organizations today. And I want to talk about some of the risks and challenges involved in managing those now at massive scale. So if we take a look back at your data center environment, say 10, 15 years ago, traditionally, most of your data and applications would run on dedicated servers that were manually provisioned by your IT and operations team to run for long periods of time. And so we applied a kind of similarly static approach to our security. So we configured the network to determine what's inside and what's outside, and we layered on defenses like our firewall to ensure that what's inside could be trusted. At least that's what we assumed. And really, a lot of the focus was around that perimeter. And when it comes to public key infrastructure, which is what we talk to organizations on a day-to-day basis about, most of the focus here was on SSL TLS certificates that were used for internet-facing assets. So these would be things like websites to ensure that users could trust them, also for web transactions like on e-commerce platforms. And the scope here was relatively limited in comparison to what we see today, which we'll get to in just a minute. But the number of certificates could be even less than 100 in many cases. But as the enterprise network grew, many organizations started to stand up their own private PKI internally, so they could issue certificates to trust things like network access, so Wi-Fi and VPN access, or device authentication as well. And that ensured that they could know who and what could be trusted on that network. And what they'd do is they'd stand up a server, configure some CA software, and start issuing certificates, oftentimes really without much consideration for the security or the policy around that. But deploying and running a PKI 10 to 15 years ago is entirely different from what we see today. So as we kind of transition to the modern IT environment, we go through this period of disruption. And this looks different for every business. Some call it digital transformation, but really it's kind of the shift from most of our data and applications, again, running on the enterprise network, to the internet really becoming the new operating platform for business. And that's primarily driven, of course, by the cloud. And that's also enabled new use cases like DevOps. So while DevOps is not defined by technology, it's more a set of principles, it really runs on this cloud engine in many cases. It relies on automation. So these development and application teams, as well as operations, need to ensure that they can deliver these applications quickly, but at the same time that typically exposes more functionality to the network. At the same time, you have a mobile workforce. So remote workers now are using possibly their own devices or corporate devices that need to access the enterprise network, as well as their email and applications. And ensuring security around that can be very complex, especially as you have a number of different platforms. And then, of course, you have the infamous IoT. So these are headless devices, and we're not always talking about, say, a coffee machine that's connected to the internet. In many cases, we're talking about life-critical devices. So these could be, in certain cases that we deal with, medical devices, so pacemakers or insulin pumps. They could be airplanes as well. Anything really that is connected to the internet in a non-traditional way, as opposed to these devices that we're used to. And building security around that has become incredibly difficult, especially as we onboard new devices into the enterprise and we're not necessarily aware of or have complete visibility into that process. So now if we look into environments today, most organizations have moved or are in the progress of moving toward a multi-cloud strategy. So now their infrastructure is very dispersed and dynamic. It's constantly changing, and it's no longer contained to a single network environment. And that's really changed the way that we need to think about security. So we've really moved from a focus on defending the perimeter to securing the data and applications themselves. And that's really brought a focus to digital identities. And this comes in the form of, again, cryptographic keys and digital certificates. What these enable us to do is know who and what can be trusted to access the network and access critical data. And what that's really done is it's completely changed the way we think about PKI as well. So there's a number of different use cases beyond what we see here now that are driving PKI as a core security technology in the business. So if we look, for instance, at containers, really kind of the building blocks that DevOps teams are working with, these, unlike your traditional servers, are being spun up and torn down rapidly, oftentimes at the fingertip of a developer that with a click of a button can launch these machines and get moving with their processes. But the problem is traditional manual management of certificates doesn't really translate well into this environment. So now you need to provision certificates very quickly, and you no longer have control over the provisioning process. So how do you embed certificates into that? That's become a major challenge. You also have Devops tools. I'll call them CI/CD tools. In the continuous integration and continuous development pipeline, there's multiple different tool sets that are now using certificates as well. So we've also changed the definition of what is PKI. Now you have tools like Ansible and Kubernetes that use certificates, use their own embedded CAs to issue those certificates as well. And enterprises are increasingly using HashiCorp Vault as well to manage those secrets, but oftentimes outside of the security and visibility of the team that's running this infrastructure over here. And that's created some challenges for them in terms of visibility and control. And then also you have cloud platforms. So now we'll call them cloud applications as well, because it really encompasses a lot more than just the infrastructure. But now you also have things like AWS Certificate Manager and Azure Key Vault. Again, we're kind of growing beyond the traditional PKI, and that's become a lot harder for security teams to maintain a single level of control over. And then as we move outside of the cloud, again, those IoT devices, how do we securely provision an identity for each of those IoT devices, oftentimes at massive scale? How do we know that we can securely authenticate those, as well as the different gateways and platforms that come along with them? And then, of course, you have your mobile devices. And similar to the cloud environment, these enterprises are also using mobility management platforms, MDM or EMM, and those are also using certificates to secure these mobile devices and the applications that are running on them. And then when we really think about the network, the idea that this network can be trusted has completely changed. So we've moved to kind of this zero trust model, where we can no longer assume that just because something's connected to the network means that it can be trusted. It's no longer assumed. So even our network gear, so things like routers, firewalls, switches, those need to be secured as well. We need to know that they can be trusted. So certificates now have taken on a much broader role, and we're talking to organizations now about not hundreds or even thousands, but tens and even hundreds of thousands in many cases. So now you end up with situations like Equifax is a prime example of that, where a single expired certificate ends up causing a major breach. And the reason for that in that case was that it resided on a network inspection device that was intended to inspect network traffic. And that application had actually gone down for, I think it was 75 days, for months, because a certificate had expired on it. Turns out that there were actually over 300 expired certificates in their environment at that time. And while it's easy to point at Equifax, I think the reality is that most organizations we talk to today are in a very similar situation. So this really leads to what we call sprawl, and that's where you have more keys and more certificates in more places. So this also includes now code signing. So code signing is being used at a much more rapid pace and for more applications. So now these private keys that are used to sign code can be found oftentimes on unprotected file systems, which could reside on, say, a developer workstation or build servers. So if we take a look at ASUS, for example, in 2019, that's where attackers were able to get into their update infrastructure and use code signing certificates to issue updates through their infrastructure to their customers when in fact it was malware, and it went undetected again for a long period of time. And that ended up impacting, I think it was close to 500,000 of their customers. So these certificates are now not just becoming a problem in terms of management, but in protection. They can be misused as well. So now we have to think about how can we protect our keys and certificates from being misused. And then also, lastly, you have to think about the life cycle of them, and that's become much more complex. So whereas before we, in some cases, saw certificates that were being issued for a lifespan of 25 or even up to 99 years just to avoid the process of having to renew them, that's no longer acceptable today. Key sizes and algorithms are now changing at a much more rapid pace, and we need to ensure that our certificates and our cryptography in general can keep pace with that. And at the same time, you have industry mandates. So the CAB form, for example, any certificates that you request from publicly trusted CAs now need to have a life cycle of 2 years, and that's even there's even talks, of course, about driving that down to 1 year, and we expect that will happen in the future. So the management and the protection of these certificates has become much more difficult at this massive scale that we now see in most organizations today. And many don't even know how many keys and certs they have, never mind when they expire or who's using them or how they're being protected. So this really all amounts to what we call the critical trust gap. I'll just put CTG. And that's really where these mismanaged keys and certificates and the backend infrastructure, the PKI as well, are resulting in a growing number of outages and potentially breaches as well, as in the case with Equifax. Outages can actually create blind spots in your network. So we need to think about it from a security aspect as well. And when we think about this, it really goes on a scale, but it starts at organizations that are using a manual solution. So this is kind of the management by spreadsheet. And they're using a spreadsheet to track their certificates and sometimes maybe some custom scripting to get those certs where they need to be. The problem is that that's very limited in scope, it's unable to scale, and it also only really covers your known certificates. There's no ability to find certificates that might be issued outside of the CAs that you have control over. And again, now we have an environment where teams are spinning up certificate authorities for specific use cases, oftentimes outside of the oversight of the security or PKI team. So what happens really here is, of course, a high frequency of outages and security risks as a result. As we move up the scale, though, we have seen organizations adopting a little more of a sophisticated approach. So they're using maybe a patchwork of CA-provided tools and their internal PKI, as well as maybe, again, some homegrown elements in there to operate their PKI environment. But they still get locked in this reactive mode where there's still unknown or rogue certs that they weren't aware of. And those are really the ones that are causing the problems. So when you take this siloed approach to managing your cryptography, it ends up leaving gaps, again, still within your enterprise. But as we move up the scale, we see organizations taking a more proactive approach. And this is really where Keyfactor kind of comes into the picture. So they're adopting tools that enable them to discover all of the keys and certificates across their environment and get a complete visibility. So they can scan their network to find those assets. They can pull them in from CAs, and they can also integrate with all of these different tools in their environment to ensure that they have a full inventory and that they can update and manage those certificates easily at scale. And what this allows them to do is not just avoid outages, but also think more proactively about how can I start using certificates to secure new use cases in my environment. So it's really become less of an IT issue and more of a business strategy. And that's really where we see the biggest shift from reactive to proactive. And then at the top of the scale, we see organizations taking a dynamic approach. And the difference between proactive and dynamic is that up until this point, we've really been talking about the keys and certificates, the digital identities. But there's a lot more that goes behind that. There's the infrastructure, the people, the policies that goes behind running a PKI. And again, the I in PKI is infrastructure. So how do you run that effectively, especially as we start to scale up these operations? Most organizations aren't able to do that in-house because there's typically, well, we all know there's a cybersecurity shortage, but especially when it comes to cryptography expertise or expertise in PKI in particular. And that becomes a major problem for them. So in many cases, we've seen organizations where, Keyfactor started off actually as a consulting firm, working with companies to build and deploy their PKI. And oftentimes what we find is those organizations would come back to us years or even months later in some cases, and they'd be stuck in trouble because the PKI that we had properly built for them originally had kind of fallen apart over time. So how do you properly maintain and scale this infrastructure as your business demands grow? That's a major challenge. But these organizations are taking a cloud-first approach. So they're offloading their PKI, the cost and complexity around that, to a trusted third-party vendor that can manage it for them. So now they have access to a highly available, secure root of trust that's managed out of house, and that allows them really to focus on their core competencies, which is how do we figure out how to, again, proactively start securing new initiatives across our business rather than focusing on incident response related to certificates or maintenance related to our PKI. And this is really our mission. So at Keyfactor, our focus is to get organizations to move up this scale and close their critical trust gap. And how we do that is through an integrated platform. So we address these three issues through kind of two components, and one is the PKI and one is the certificate management. So if we look at certificate management, we have a platform that enables these organizations to discover, monitor, and automate the lifecycle of all of their keys and certificates. So they have a complete inventory and they have complete control over that. And they can also protect those from misuse. So in terms of code signing, for example, we can ensure that those code signing keys are locked away in an HSM, and that even when developers need access to them, those keys don't leave that HSM. They can easily still sign code, but the security is still in place. And then when we think about the PKI problem, managing the infrastructure, what we do is we offer a PKI as a service. So we will actually stand up a dedicated private PKI hosted in the cloud with an offline secure root of trust. And we ensure that that's always available and always secure for your organization. So we've actually combined those two components into a single platform that's delivered from the cloud, and we call that Keyfactor Command. And what that's really allowed our customers to do is move from their traditional IT environment to this modern multi-cloud environment today, and not just react to this disruption, but actually innovate with it and keep their security game ahead of it.